Okay, just before we look at examples that involve solving equations that have the unknown or the pronumeral as the index, what I'm going to introduce you to first of all is the logarithm button on the calculator, which is this button here. There's actually two of them. There's this one here called log, which is actually log base 10. And there's this one here called natural logarithm, the LN key, which in year 10, we're not going to use that key. We might have a quick chat about it at some point. But the key that we're going to use for all these examples is log base 10 at the moment. So just to give you an example of how that works. So all these years, you're probably looking at your calculator thinking, what's that log button do? Well, what's that got to do? What's involved with that? I've never used it before. Well, now we are going to use it. So for example, if I wanted to do log base 10 of 1,000, you know that the answer is going to be 3 because 10 to the power of 3 is 1,000. Sure enough, we get 3. Let's say log base 10 of 50. We get 1.698, whatever. That means that if we take the number 10, okay, and raise it to that power, okay, so whatever the previous answer was, we'll get 50. Okay, so that's how that works. In fact, anything that involves solving an equation involving logarithms and exponentials, there is actually a way to test the answer. So to go back and sort of do it in reverse. If it's a logarithm, test it by substituting the answer into an exponential and see if you get back to where you started. Okay, so that log button there is going to be very useful. Okay, now to look at the examples for this video. Okay, so I might just adjust the camera a little bit, just hopefully get the whole board there. Yep, I think that's good. Okay, so first equation, we have 3 to the power of x equals 100. Okay, so the first thing we're going to do is if we're going to take the logarithm of base 10 of both sides. So what we're going to do is we're going to say log base 10 of 3 to the power of x is equal to log base 10 of 100. Okay. Now the right hand side we already know what to do with that. Log base 10 of 100 is just going to be 2. But the left hand side we don't know what we're going to do with that just yet. However, we do know that x is an index and log law number 3, the x can come out to the front. So the next line will be, okay, x log base 10 of 3 is equal to log base 10 of 100. Now we can evaluate the right hand side already. So x log base 10 of 3 is equal to 2. Then we're going to divide both sides by log base 10 of 3 and then x will be the subject of the formula. So x is going to be equal to 2 over log base 10 of 3, and then we can use the calculator now to evaluate that solution. So 2 over log. Now notice that the log button on the calculator doesn't put a little base 10 there. There's a little 10, a subscript 10 after the G. When you see the word log in the calculator on the calculator screen, we know it's got to be base 10. Okay, so anytime we press the log button, the calculator works it out to base 10. So log base 10 of 3, and we get 4.19. Okay, so we'll round it off to 3 significant figures. Okay, so 3 significant figures. Okay, test the answer if you like. So 3 to the power of 4.19. Do we get an answer that's pretty close to 100? And we do. 99.8. Of course, there's a little bit of rounding error, but I think we're reasonably confident that that's the right answer. Okay, what about part B? I'll just move the board up a bit. Okay, so sorry, just the camera a little bit more. Part B, 7 to the power of n minus 2 equals 1 over 2 root 3. We do what we do with part A. All right, let's take the logarithm of both sides. And the reason why we do that is because we want this n somehow to become the subject of the formula. Okay, and the only way to do that is if you take the log of both sides of the equation. What you do to one side, you do to the other. Okay, so let's do that first. So log base 10 of 7 to the n minus 2 is equal to log base 10 of 1 on 2 root 3. Next thing we do is the n minus 2 comes out to the front. So we have n minus 2, okay, put that in brackets, times log base 10 of 7 is equal to log base 10, 1 on 2 root 3. Now we can make n minus 2 the subject of the formula by dividing the right hand side by log base 10 of 7. So that's going to be log base 10, 1 on 2 root 3 divided by log base 10 of 7. Then we add 2 to both sides, so n is equal to 2 plus log base 10 of 1 over 2 root 3 divided by log base 10 of 7. Okay, we can evaluate that now in the calculator, so 2 plus log, okay, fraction key, 1 over 2 root 3, okay, close bracket, divided by log of 7, so log base 10 of 7, and we get 1.36. Again, we're going to round it to three significant figures. Let's we can test the answer as well. I might just do it quickly. If we do 7 to the power of n minus 2, so 1.36 minus 2, okay, we get 0.288. So 1 on 2 root 3, do we get 0.288 here, or pretty close? Yeah, pretty close. Okay, as long as the answers are reasonably close, I think we're confident enough that the answer is correct. And the last one, we have log base x of 20 equals 5. This time around, we don't even know what the base is, in fact. So this one's going to be a little bit different. So what we're going to do is we're going to rewrite this logarithm in exponential form. So this logarithmic expression in exponential format. So x to the power of 5 equals 20. Okay, remember that's how we read an exponential. X to the power of 5 equals 20. Right? They mean the same thing. This time around though, how do we make x the subject? We take the fifth root. Okay, so what we're going to do is we're going to take something called the fifth root. Okay, so it's a square root with a little 5 is equal to the fifth root of 20. Okay, so the fifth root and the power of 5 cancel, so we have x is equal to the fifth root of 20, and that's going to be roughly equal to, okay, shift, and so we press this key here, so I should introduce that next to the word, just above next to the word hex, if you're using an FX100 calculator, but it's just above the x to the power of button there, so it's in yellow. So we have to press the shift key first, press the button in yellow, put the 5 there, so that's the root, that's the order of the root, so it's a fifth root, and we put a 20 there, so that's going to be 1.82. Okay, so let's just check and see if that's roughly correct. If we put 1.82 to the power of 5, do we get roughly 20? And we get 19.97, so, or 969, so that's fairly close.